Okay, so a full-fledged question where we'll be approximating a binomial distribution into a normal distribution. Look at the steps carefully, note them down, okay? Now, we're given that there is x, which is binomially distributed with n as 100 and p as zero point 0.7. So I'll be writing here that my n is 100, my n is zero point 0.7, and my, sorry, this is p, and my q is zero point 0.3. I'll quickly find this np to make a quick check that if it is greater than 5, so yes, this is 100 times zero point 0.7, that is 70. That is your np. And similarly, your nq, that is 30. So they are both greater than 5, okay? So it means we can approximate this binomial distribution into a normal distribution. And here we have to find the probability that your x is less than 75, okay? When your x is less than 7, we have to find this. So now I would say that let y is normally distributed. So when I go into the normal distribution, I need to have its parameters here. So its mu is going to be np, which is, we have already calculated, that is 70. And its variance would be npq. So that is 70 into zero point 0.3. Is that 21? Yes. Should I check this?
Yes, sir.
Yeah, this
21.
is 21. Okay. So I would be writing this here that let y is a normal distribution with the mean 70 and the variance 21. So finding this probability x is less than 75 would mean to find the probability y is less than. Now here is the situation where you go for the continuity correction here, or the continuity error over here. So if you are not good enough onto it, you just make a line here 75, and this is your 74.5, this is your 75.5, and you just have a, like, bar here. It says before 75, so that means it's going to be before 74.5. So this y is going to be before 74.5 when you move from the discrete to the normal, I mean continuous, and binomial to the normal. Now, this has become a question on a normal distribution, and you guys are quite familiar with this method. Uh, this will, you will straight away go for the standardization of this. So this z would come in here, where your z is a standard normal distribution. So this would be less than 74.5 minus 70 over the square root of 21. So the rest is a piece of cake for you people if you have already practiced this normal distribution. So this is over the square root of 21. So this is going to be 0.982. This is phi of 0.982. Okay, we'll go to the table then. 0.982. Okay, oh, I'll have to go this. 0.9. Yeah, here it is 0.9. 0.9, 1, 2, 3, 4, 5, 6, 7, 8. 0.98. And here is this 2. So this is 0.836, sorry, 837. This is 0.837. So for this binomial distribution, the probability for x to be less than 75 is going to be 0.837. So this is basically your probability x is less than 75. You see, we have been using the x, y, and z. So when I write x, this means I'm referring to this binomial distribution. So this is a 5 marks question. I'm going to give you a recap of this. you were given a binomial distribution with its parameters, which is n and p over here. Okay, you made a quick check that if your np and nq, they are both greater than 5. Yes, that's fine. If you don't even do that, like the question is saying that you make an appropriate approximation, so this is understood that these two conditions would be satisfied. Anyhow, just for the sake of the information or the practice, I have made a quick check over here. Okay, so this was the question from the binomial distribution. We had to find the probability that x is less than 75. Then we assume that there is a normal distribution which has a mean 70 and the variance 21. So you use these two formulas here to get to, these are the formulas here you have been using to find the mean and the variance. Once you have done that, then here is the continuity correction step here. So less than 75 would mean less than 74.5. And here you standardize your normal distribution into a standard normal distribution. You got this phi of 0.982. You check from the table and you got the answer 0.837.